and welcome to another lesson from Level Up Mathematics. In today's lesson, we will be learning how to convert a quadratic equation that's written in standard form into vertex form. Before we do that though, let's look at some advantages and disadvantages between standard form and vertex form. So let's start with standard form. Standard form is written whenever your quadratic equation is in the form f of x equals ax squared plus bx plus c. Now, one advantage to this form is that your y-intercept, where it touches the y-axis, is immediately visible to you because it's always the ordered pair 0, comma c. It's also easy to determine the direction the parabola opens. So it'll open up if a is greater than 0, and it will open down if a is less than 0. It's also easy to determine whether the parabola is stretched or compressed just by looking at the value of a. Now, there are some disadvantages to standard form. One of them is that the vertex is not easily, it's not really obvious. In fact, to find it, remember you have to use this formula. So that's kind of a disadvantage for standard form. It's also, in standard form, it's also harder to see how the parabola shifts from the parent function, f of x equals x squared. Now, vertex form is a little bit different. Vertex form looks like this. F of x equals a times the quantity x minus h squared plus k. So the nice thing about vertex form is the vertex is immediately visible. It's just the point h, comma, k. It's also easy to determine the maximum or the minimum value of the parabola, and that will always be k, the value of k. It's also easy to determine how the parabola will shift from f of x equals x squared. Now, one disadvantage of vertex form is that the y-intercept is not obvious. To find the y-intercept, you would have to set x equal to 0 and then solve for y, and that can kind of be a lengthy process. So if you're needing to know the y-intercept of a function, it's generally better for the function to be written in standard form. Okay. Now, in example 1, we're just going to kind of look at the differences between standard and vertex form. It says determine which form each quadratic function is written in, and without graphing on your calculator, state as many facts as you can about that parabola. So look at problem A. We have f of x equals negative 4x squared plus 3x minus 5. So right away, I recognize that this is standard form that it's written in. And let's talk about what is very obvious to us when something is in standard form. Right away, if something's in standard form, I can identify the y-intercept because it's just the value of c. So 0, negative 5. So I right away know where that graph is going to touch the y-axis. Okay. The other thing that I can tell just by looking at this function is from the value of a being negative. So I know that this parabola is going to open down because a is less than 0. In other words, a is negative. All right. The other thing I know from the value of a is that this parabola has been vertically stretched. Vertically stretched. All right. All right, problem B. We have g of x equals 1/2 times the quantity x plus 3 squared minus 2. Pause the video and write down the form that you think this equation is written in, and then as many facts about this quadratic function as you can. All right, welcome back. All right, hopefully you said that this parabola was written in vertex form and that you identified the vertex to be -3, -2. Maybe you said that the graph opens up. And maybe you said that the graph was vertically compressed because the a value was between 0 and 1. All right, now, it is possible when you have a quadratic function that's written in standard form to convert it to vertex form. And to do that, we use a process called completing the square. Completing the square. So let's talk about a little bit about what that means. So when I have a binomial expression, like we do in example 2, it says find the value of c that would make each trinomial below a perfect square trinomial, and then write the perfect square trinomial in factored form. So the way that we find the value of c that will make this a perfect square trinomial is we take the value of b, divide it by 2, and square it. In other words, take the middle number, divide it by 2, and then square it. So in this problem, 14 divided by 2 is 7, and 7 squared is 49. So I can rewrite x squared minus 14x plus c as a perfect square trinomial like this. X squared minus 14x plus 49. So there is our perfect square trinomial. Now, to factor a perfect square trinomial, you simply take the square root of the first term, which is x. You take the second sign, which is, or the first sign, which is minus, and then you take the square root of the last term, which is 7, and then parenthesis squared. So factoring a perfect square trinomial would go to x minus 7 parentheses squared. All right, let's look at another example like that. So we have x squared plus 16x plus c. We want to know what c should be in order to create a perfect square trinomial. So remember, we're going to take the middle number b, divide it by 2, and square it. So our middle number is 16. Divide that by 2, and square it. So 16 divided by 2 is 8. 8 squared is 64. So let's write this as a perfect square trinomial. That's our first answer. And then factor that expression. So to factor it, take the square root of the first term, the square root of the last term, and use the first operation symbol, so plus, and then squared. X plus 8 parentheses squared. All right, pause the video and try problem C on your own. All right, welcome back. Let's see how you did. All right, so I did 22 divided by 2 squared, which gave me 121. So I wrote this as a perfect square trinomial, x squared minus 22x plus 121. And then I factored that expression to be x minus 11 parentheses squared. All right, example 3. Convert each of the following from standard form to vertex form, and then identify the vertex. All right, so the first thing you're going to want to do is we're going to group up the first two terms. So we'll say y equals x squared plus 6x plus blank and then plus 10 plus blank. All right, so what I did basically here is I moved that constant over, and what I'm going to do now is I'm going to figure out what number would I need to make that expression inside the parentheses a perfect square trinomial. So we learned this on the previous page. Take your middle term, divide it by 2, and then square it. So 6 divided by 2 is 3, and 3 squared is 9. Now you can't just add 9 to the parentheses. You must, oh, I made a mistake. You must also, right here, we want to subtract 9. Now let me tell you why we did that. If I add 9 and subtract 9 to an expression, 9 minus 9 is 0. I really haven't changed the expression because what we've added adds up to 0. Okay. Now, in your second step, you're going to factor what's inside the parentheses. So this would be y equals, remember, take the square root of your first term, the square root of your last term, and square it. And then you'll take 10 minus 9, which is positive 1. So now we've converted from standard form to vertex form, and we just need to identify the vertex, negative 3, positive 1. All right, let's try that one more time. We have y equals x squared minus 8x plus 5. So what I'm going to begin by doing is I'll make a parentheses, and I want to group up the x squared, the minus 8x plus something, and then on the outside of the parenthesis I'll put plus 5 minus something. So we're going to add some number and subtract some number. Now remember, to figure out that number, you're going to take your middle number, divide it by 2, and square it. So 8 divided by 2 is 4. 4 squared is 16. So I'll add 16 here and subtract 16 here. All right, so in our next step, we're going to factor this. Remember to take your square root of your first term, which is x, and your square root of your last term, which is 4, and then square it. And then 5 minus 16 would be negative 11. So now we've gone from standard form to vertex form, and we just need to identify our vertex as 4, comma, negative 11. All right, now let's talk about what to do if your coefficient is not 1. So in example 4, it says convert each of the following from standard form to vertex form, and then state the vertex. So if your expression does not have a value of a, you're going to need to divide out the common factor before you start. So in problem A, we would have y equals 2 parenthesis, and I want to divide those first two terms by 2. So 2x squared divided by 2 gives me x squared. Negative 8x divided by 2 gives me negative 4x. Then I'm going to add a number, then plus 11, and I'll subtract that same number. Okay, now we're going to find the number that makes a perfect square trinomial. So we're not using 8 now, we're using the 4. Okay, so I'm going to take 4 divided by 2 and square it. So 4 divided by 2 is 2, and 2 squared is 4. So I'm adding 4 here. Now be very careful. You are not subtracting 4 from the 11 because this, we have a 2 on the outside of our parentheses. So 2 times 4 is 8. So what we're subtracting here is 8. All right. Now I'll write this in factored form. 2 parenthesis x minus 2 parenthesis squared, and 11 minus 8 is positive 3. So this is, I'm going to box this in because this is called vertex form, And here's what I know about this vertex form. We have a vertex at positive 2, comma 3. We also know it's been vertically stretched by a factor of 2. Okay. All right, let's try that again on problem B. We have y equals negative 3x squared plus 30x minus 72. So first thing I want to do is divide out a negative 3 from my first two terms. So negative 3x squared divided by negative 3 would be positive x squared. 30x divided by negative 3 would be negative 10x, and then plus something, and then minus 72 minus something. All right, let's see what we are going to add to complete the square. So take your middle number, 10, divide it by 2, and square it. So 10 divided by 2 is 5, and 5 squared is 25 here. So I'm adding 25 here, but over here, I have to subtract negative 3 times 25, which is negative 75. All right, so y equals negative 3. Factor your parentheses. That would be x minus 5 parentheses squared. And then negative 72 minus negative 75 would be positive 3. So there's your vertex form. So here my vertex is going to be 5, comma 3. I know this parabola would open down, and it would be vertically stretched by a factor of 3. And that concludes today's lesson, converting from standard form to vertex form.